So the next part of our module is about future value. Okay, so when we say future value or FV, this is the value of a current asset at a specified date in the future based on an assumed rate of growth. Okay, in other words, when we say future value, this simply means the value of the money after a period of time. So in future value, we will consider the principal amount that is compounded at the interest rate, and we will also consider the period of time, okay, as the number of years, months, or whatever may the time period be based, okay, as the investment is being placed. Okay, so here, before we go to the discussion of future value, so let us first have a review of your simple and compounded interest. So here, when we compute for the simple interest, okay, so that simply is the principal amount multiplied by the interest rate and the time period. So this is how you determine the interest or the simple interest after a period of time. Let us say, for example, after a year. So under the future value concept, what we are going to adopt is the compounded interest. So here, when we say compounded interest, okay, normally this applies to the second year and thereafter. So in our illustration here, we use second year, okay, to compute and to illustrate how to determine the compounded interest. So in this case, to solve for the compounded interest, this is the same, somewhat the same with that of the simple interest. However, in this case, we will add the interest that we have earned in the previous year or previous period in the principal amount to get the interest in the current period. So to do that, to solve the compounded interest, that is the principal amount, as mentioned earlier, plus the interest in the previous period, and then this the sum of this will be multiplied with the interest rate and the period of time. So this concept will be applied under the future value concept. Okay, so to continue, by the way, in our discussion for future value and present values, we will have two cases. So the first case is for single cash flow. That is, we only make the investment once, okay? Regardless of the number of years that you will wait for that money to be claimed. Again, under the single cash flow, there is only one time investment. Okay, again, investment is made only once. Normally, that is made during the current period. Okay, for the second case, we will be discussing also future values for annuities. Okay, so later in the later part of this module, we will have the detailed discussion of that. But for now, let us focus on the future value for single cash flow. So again, I would like to repeat, this is the investment where it is made only once, normally during the current period. So we have here an example. So the question here actually is that if you have 1,000 pesos and you will place that now in an investment that will earn 10% interest or annual interest for 5 years, so how much will be your 1,000 pesos after 5 years? Okay, so how to solve for the future value for 1,000? So we have here the table for the solution. Okay, so we have 3 columns. If you could notice, we have the year, calculation, and the future value. So in this case, in the column for the year, since our problem suggests that the investment will be placed for a 5-year period, so we have here year 1 to 3, 4 to 5 years. Okay, for the calculation, so in this case, we will have this one. Normally, your future value, as mentioned earlier, is somewhat the same with that of the simple interest concept. But as we go along on the next periods, we will apply the compounded interest. Okay, so here, to solve for the future value for the first year, that is principal, okay, times the interest rate, okay, that is 10 percent as mentioned earlier in the problem, and then the time. Okay, so in this case, based on our solution, so the interest here is equal to 100. So to solve for the future value, your future value actually is the principal plus your interest. Okay, so that's why our future value here is equal to 1,000, which is the principal amount, plus our interest of 100 for the first year. So that's why it's 1,100. Okay, so moving on to the next period, year 2. So for year 2, our future value here, we will use the future value that we have in the first year. So if you could notice in our illustration, so the future value here is 1,100, or that is now the new principal amount, or in this case, we refer to that as our future value. So 1,100, and then we will multiply that again with our interest rate for the second year. Okay, and then in this case, our interest is now 110. Okay, so 110, and then we will add that to the future value that we have in the first year. That's why in the second year, it's now 1,210. Okay, so for the next year, third year, fourth year, and the fifth year, we will use the same concept. So again, we will use the future value in the second year, and then multiply it with the interest rate, okay, and then add that to the future value in the previous year to get the future value for the current year, and so on. So in short, if you are the investor and you place your 1,000 pesos with the interest rate of 10%, so after 5 years, your 1,000 will become 1,610.51. That is the future value of 1,000 after 5 years, earning 10%. Okay, this is our future value. Okay, so to illustrate in another way for you to understand it better, so we have here the following. Okay, so this is another illustration or a way of illustrating how did we arrive at the future value after 5 years. So if you could notice here, we have year 0, meaning to say that is now the current period in which you placed your investment of 1,000. Again, we are talking about single cash flow, so you only place your 1,000 once only. Okay, that is placed once, one time. So you did that here in year 0 in the current period. So in this case, as you place your investment and the time has not passed by yet, so therefore there is no movement in your future value. So the same as, or the value is still 1,000. However, after 1 year of placing that investment, so based on our table earlier, so your 1,000 earned an interest of 100. That's why it now becomes 1,100 after 1 year. Okay, then in the second year, third year, fourth year, and in the fifth year, this is the period or the year in which you can already claim or you can withdraw your investment. But now, it has a future value of 1,610.51 because again, if you could notice, time value of money. Okay, in this case, it increases because you place that into an investment. Okay, however, if you did not place an investment in the current period, then you cannot earn anything. So you will not have this 1,610. Okay, so this is the concept of time value of money, that you have to have the money now so that you can invest it here and earn 10% for 5 years. Okay, for example, if you did not have 1,000 now, so you did not place it in this investment, okay, so there is no interest or benefit that you will receive. Okay, so that is the concept again of time value of money. So again here, these are the future values of 1,000 for the next 5 years. Okay, so the next topic under future value is how to determine the future value using the table for future values. Okay, normally, if solving for future value based on a simple and compounded interest computation, you will have a hard time for doing that, especially if, for example, the period of investment is 20 years. So, it is time consuming, okay, and complicated, okay, at the same time because you have to repeat that 20 times, okay, and add them up. However, in this case, for efficient way of solving your future value, there is actually a table that is available, okay, for us to use in solving for future values. So here, along with our discussion later, I am going to present the table at the same time. So this first table is for the future values. Okay, to have a better and simple way of determining the future value of money, the table was shown, okay, or will be shown in the figure in the next slide for future value. So the interest rate or growth rate for several years are already given in the form of interest factors. So in this case, we will use the factors or interest factors to solve for the future values of money. So this is for the purpose of computing future value, which is equal to the principal amount plus your interest. So this will make your computation easier. Okay, so this is the table that we are talking about. Okay, you cannot see it very clear because it's very... Okay. Okay, so in your module, you also have the copy of that, correct? So here, we will use table 1. So in this case, table 1 refers to future value. Okay, this is interest factor for single cash flow. So again, we are still in the single cash flow discussion under the future values. Okay, so again, this table 1 will be used for single cash flow. Okay, so if you could notice in this table, we have the parts. And then as we discuss the parts, we will also discuss at the same time the steps on how to use this table to compute for the future values. Okay, so here, the table has different parts as mentioned, and they play an important role, especially when determining what interest factor will be used for a specific problem. So to better explain these parts and the steps on how to use this table, let us use the example that we discussed earlier. So again, to repeat, the future value of 1,000 compounded at 10% annual interest rate at the end of 1 year, 2 years, up to 5 years. Okay, or meaning to say we will solve for the future value of 1,000 for 5 years. Okay, with 10% interest or annual interest. So how to solve this using the table? Okay, so first, okay, if you could notice here, we have the columns. Okay, these are our columns here. So in the first column right here, okay, this actually shows the number of years. Okay, so if you're going to expand this one so that you can see it clear. Okay, this column or this first column refers to the number of years. So if you could still remember in the problem that we used, we will be placing the investment for 5 years. So mean to say, in this column right here, we will choose the fifth period, or that refers also to the fifth year. So right here, if you could notice, we have the arrow, color yellow arrow, and the circle. Okay, so this is our starting point. So this is how to use the table. First is to identify the period. So again, in our example, it's 5 years. So you will have it here in this part. Okay, so the next part is our rows. Okay, if you could notice, we have there the rows. Okay, under the rows, in the table, we have the percentage right here above. Okay, so I'm going to expand it. So in this case, in the rows section, we have the following. So you could notice there that it indicates there the interest, okay, because it is represented by a percentage. So this one is for 1%, 2%, and so on. So again, in our problem, the interest rate is 10%. So we will locate the factor here under 10%. So the next step is to locate the interest factor. So normally, to use the table again, all you have to do is to locate the number of period, that is 5 years, and then our interest rate, which is 10%. So meaning to say, the interest factor that we will use to solve for the future value is 1.6105. Okay, this is our interest factor. Okay, using the table. Okay, so after that, based on the table, okay, after you have already determined, okay, the factor to be used, that's 1.6105. So to solve for the future value of 1,000 after 5 years with 10% interest, so therefore, 1,000 times 1.6105, okay, that is equal to 1,610.50. Okay, so if you could notice, this is actually easier compared to the first one that we have. Okay, if you could still remember, let us just go back with this one. Okay, so this one is, you have to multiply every year the principal or the future value with our interest rate and so on. Unlike in this case, using the table, all you have to do is to locate it and then multiply it with our interest factor, and then you will have the future value. Okay, so this is what we are talking about, using the table to make your computation easier for determining the future value. So again, this one is the same with that of the first illustration that we have before we used the table. Okay, so that's how it is. Okay, using the table for future values. Okay, next. So what about if you're going to solve for the future values every year. Okay, just like what we have in the previous table every year. Okay, so all you have to do is to use the interest factors also under the 10% column starting from year 1 to year 5, which will also yield the same amount as in the previous computation earlier. So in this case, if you would like to determine how much or what is the future value at the end of year 1, year 2, year 3, year 4, year 5, so again, we will just use the table and use the future value. So again, for example, in year 1, okay, 1,000, our factor is, again, we will look into the 10%, okay, column. So this is our factor for year 1. So that's 1.1, and then we will multiply it with 1,000. Okay, so that's 1,100. Next, for year 2, our interest factor is now 1.2100. Again, we will multiply it with 1,000. Then we have this future value for the second year of 1,210, and so on until in the 5th year. So again, these interest factors can be found in our table right here under the 10% interest for each period. Okay, so again, we will yield at the same value, okay, of 1,610.50. So that is for future value for single cash flow. Again, we only make the investment once in the current year. So what about in the second case? So the second case is for ordinary annuities. Okay? So here we will be discussing only for equal amount of investment, because there are cases that investment for the next years is different from that of the current or the first year. Okay, but in this case, we will assume that the investment is equal every year. Okay, so to start, when we say annuity, this term normally means a stream of equal payments made at a regular time interval. So just like what we have mentioned, or if we will compare this with single cash flow, under the single cash flow, we will only be investing once in the current year. However, in the case of annuity, the investor is going to place the investment every year. So in this case, if we will use the previous example, it means that 1,000 will be provided every year for the next 5 years. Or in other words, based or according to this table, the investor is going to place 1,000 in the year 1, and then he is going to invest again another 1,000 in year 2, another 1,000 in year 3, another 1,000 in year 4, and another 1,000 in year 5. So, in short, each year the investor will provide or invest 1,000 and will be added to the previous investment to earn the interest for 5 years. So, this is the difference of annuity with that of the single cash flow. So here, when we say ordinary annuity, okay, normally this is one in which the payments or receipts, when we say ordinary annuity, the investment is made at the end of each period. So this type of annuity is also called as regular or deferred annuity. So here, we will use the table for easier determination and computation of our future values. Okay, so this one, table 2. In the first case, under the single cash flows, we use table 1. Okay, for annuity, we will use under the future value. Okay, we will use table 2, future value for annuity. Okay, so the table is just the same with that of the previous table 1. the same parts. It has columns for the period of time or years, and it has rows for our interest rate. And then we will locate in what factor, interest factor, are we going to use to compute for the future value. Okay, so we have here an example to use the table. So, using the same example earlier, but the investment of 1,000 will be made regularly at the end of each period, meaning to say the investor is going to provide 1,000 every year for the next 5 years. So again, the investment is 1,000 every year at 10%, or it will earn a 10% interest for 5 years. So how to compute for the future value? Okay, again, the same thing that we have done in the previous uh, illustration. So we have here the table. Okay, normally, if you could notice here, oh wait, okay, this is our table, by the way, sorry. Okay, so for our table, I mean, for annuity, okay, table 2. So in this case, the same manner of locating the interest factor. Okay, so first is we will locate the number of periods. So this is in under 5-year period, and then we will have it also under the 10% interest. So in this case, our interest factor, if you could see there in the screen with the yellow arrow and circle, so that's 6.1051. This is our interest factor, okay, that we will use to solve for the future value. So to use that, okay, so to solve, I mean, we have here 1,000 times our interest factor from table 2. So meaning to say, after 5 years, if you're going to place 1,000 every year, okay, the future value of your investment after 5 years will become 6,105.10. So this means to say that the investor will earn a total of 6,105.10 after 5 years with interest of 10%. That is if he will provide 1,000 each year for 5 years. So if you could notice, the table makes our life easier when it comes to solving future value. So again, all you have to do is to locate the interest factor and multiply it with our investment. Okay? So next is, what about if you would like to solve for the annuity every year? Okay, if to do that, we will use table 1. Okay, so the same. So in this case, we will use the table. Okay, in the previous case, under the single cash flow. But this time, okay. So if you could notice here, in our future value for single cash flow, the answer is this one under in the 5th year. But in the case of annuity, because every year you are investing 1,000, so we will add all of this. Actually, for year 1 to 5, we have the same computation in the previous discussion in our single cash flow. But for under equity or annuity investment or case, all you have to do is to add all of these values to get our future value under the annuity or ordinary annuity. So that's also 6,700. But if you could notice, we have different value. In this case, we have 6,715. But in the previous answer, using the table for annuities. So the answer is 6,905. So there is a difference due to the rounding off of numbers, but it's still or it falls under the same level or amount. Okay. So again, if you would like to determine the future value of your investment every year, you can use the single cash flow and then add all of these future values to get your future value for annuity. Okay, so that is for uh, our future value discussion.